Hi students, today we are going to discuss about the spring mass pulley system number 3. So this is a rigid support in the ceiling. Here is a spring. The spring constant is K and the string is attached to the ceiling. It passes over a pulley and connects a spring which is also attached to the ceiling. Now from the pulley, midpoint of the pulley, another string is attached and to the lower end of the string a mass M is suspended. So that T is the tension in the string and T is the tension in the left part of the string. The same tension is going to act above the spring. Okay. Now this dotted line indicates the equilibrium position. Okay, so this is the equilibrium position of the pulley. This is the equilibrium position of the mass. Now I am going to stretch the mass in the downward direction with a velocity v. Okay, so it is initially at 0 velocity. Now it is attaining a velocity v in the downward direction, so that it is brought down from its initial position through a distance x. So now you can see the left point and the right point on the pulley, both of them will be displaced by the same amount. So this end will also come through a distance x. The left end also will come through the same distance x, so that the spring is stretched through a distance x1, which must be equal to x plus x. Is it not that? So first this displacement produced in the spring is x1 must be equal to x plus x. So this is equal to 2x. Now the mass is accelerated in the downward direction. So this is the direction of acceleration. Okay. This m into a, this force m into a must be equal to the tension acting at the top 2 points. So T plus T must be equal to what? M into a. So here T plus T is equal to M into A, or 2T is equal to M into A, or tension T is equal to MA divided by 2. This is another required equation for us. So T is equal to MA by 2. So I will call it as equation 1. You look at the spring, the arm which is containing the spring alone. So this tension T must be equal to minus K times x1. Okay. So for the spring, the tension T must be equal to minus K times x1, and this is also equal to minus K times x1 can be written as 2x. So K into 2x, and this is our equation 2. So equation 1 and equation 2 have the same left hand sides. I am going to equate them. So MA by 2, okay, from equations 1 and 2, MA by 2 must be equal to minus 2kx. So what is A equal to? Therefore the acceleration A is equal to minus 2 into 2 is 4, k divided by m into x. This is our equation 3. Okay. So the acceleration of the mass is equal to what? Minus 4k by m times x. But from the definition of SHM, okay, from the definition of simple harmonic motion, the acceleration also is equal to minus omega square into x. So this is our equation 4, where omega is the angular frequency of SHM. So I am going to equate 3 and 4. So minus omega square is taken on the left hand side, and this is equal to minus 4k by m. So this is minus 4k by m into x. So this minus and x get cancelled. Okay. So x and this minus get cancelled. So omega square is equal to what? 4k by m. Therefore omega is equal to square root of 4k by m. And this is the required expression number 5. This is for the angular frequency 2 pi nu, 2 pi f. Okay. So now the period t. So I want to get an expression for the period of oscillation t is equal to 2 pi by omega. So this is equal to 2 pi divided by square root of 4k by m. Or final equation t is equal to 2 pi into square root of this inverse is coming to the numerator as m divided by 4k. So this is m divided by 4k. This is the final expression for the period of oscillation. Now if you want the natural frequency, the natural frequency f is equal to 1 by t. So this is equal to 1 by 2 pi into square root of 4k by m. So this can be called as equation 7. Okay, my dear students, we have derived an expression for the period of oscillation as well as the frequency, natural frequency of oscillation for the spring mass pulley system. By conservation of energy also we can arrive at the same equation. So let us try from conservation of energy. Okay. So next we derive from conservation of energy. The total energy of the system remains constant. Now the total energy of this spring mass system is equal to the potential energy stored in the spring plus kinetic energy of the mass. So the total energy E total is equal to half k into x1 square plus half m into v square. So this is equal to half into k into, in place of x1 shall we substitute 2x. So x1 square becomes what? 2x the whole square plus half m into v square. So this is now equal to k by 2. So this is equal to k by 2 into 4x square. Okay, 4x square plus mv square by 2. So m by 2 into v square. Now since total energy is constant, dE by dt must be equal to 0, isn't it? So dE by dt is equal to this k by 2. This is k by 2 into k by 2 into 4x the whole square is 4 into 2, 8 into x. Okay, so this becomes 8x into dx by dt plus m by 2 into dv, that is 2v into dv by dt. So I have differentiated each term with respect to time. So left hand side is dE by dt is equal to 0 because the total energy must be constant always. So 0 is equal to, so this 2 4s are 8. So this is 4kx into dx by dt plus this 2 and 2 get cancelled. So this is mv into dv by dt. Okay, so now you take dx by dt is equal to the velocity v. Okay, so now this is also equal to 4kx into v. Rate of change of displacement is what? Velocity plus mv into rate of change of velocity is equal to what? The acceleration a. So I equate these two terms so that mva, so m into v into a is equal to minus 4kx into v. So I have retained this term on one side, I have brought this to the other side, it becomes a negative. So this v and v now get cancelled. Okay, v and v get cancelled. Therefore what is a equal to? Acceleration a is equal to minus 4k by m into x. Okay, also we know that okay, from the simple harmonic motion this is also equal to minus omega square times x. So equating these two I get omega square is equal to, so minus minus xx get cancelled, omega square is equal to 4k by m. This implies what? Omega is equal to square root of 4k by m. Therefore time period is equal to 2 pi by omega. So this is equal to 2 pi into square root of So m by 4k, this is m divided by 4k. And therefore the natural frequency is equal to the reciprocal of the time period. So this is equal to 1 by 2 pi into square root of 4k by m. So we are getting the same equation for the period. See equation 6, t equal to 2 pi into square root of m by 2k. Here also we are getting the same equation. And f is the reciprocal of time period 1 by t is equal to 1 by 2 pi into square root of 4k by 2. So we have confirmed that the natural frequency as well as the period of oscillation by two methods. Okay, one is by the actual definition. Then second one is from the conservation of energy. I hope you must have understood well. Fine.